So as we become more comfortable with using our product, quotient, and power rules, we can take a complex logarithm and use those rules to expand this and write this as lots of little logarithms. So what we're going to do is we're going to kind of unwrap the package. And I want you to think about your grandma and you've given her a present and she says, oh, this paper is so beautiful. I love it. I want to save it. I'm going to take it apart very carefully and unpackage it. That's what we're going to be doing here. So we're going to take this and, gently tear the tape off and flatten out the seams so it's nice and smooth and lots of little logs that are easy to deal with. So we're going to spread it out. And I wish I could say you were always going to do these properties in the exact same order, but that is not necessarily the case. So again, I want you to think about peeling this open and taking it apart piece by piece. All right, so we're going to start with natural log of the cube root of x divided by e to the fourth times y. And all of that is in my argument, right? So we're going to write this with lots of little basic arguments. So the first thing we might do is we think about this cube root. And moving ahead in math, rewriting radicals as rational powers is something that we do quite often. So I'm going to rewrite this. So this is now x to the 1/3 power divided by e to the fourth times y. So that's just a really common thing that we do to help us simplify. So the next thing I'm going to notice is I have this fraction. That's the most unhappy part of this to me. This makes me the most upset. So I want to get rid of the fraction. And if I use my quotient rule, that means I can say the log of the numerator minus the log of the denominator. So my numerator is x to the 1/3. And then I'm going to have a minus here, the log of my denominator, natural log, e to the fourth y. So see, I've spread this out and I've got two littler logarithms. So we want to continue this process. And looking at this second logarithm, I can see I still have a product inside. So a product rule says that I can write this as the sum of two logarithms with each factor as the argument. So I'm going to leave my first term, x to the 1/3, minus, and what I end up with here is the natural log of e to the fourth plus the natural log of y. Now, I left my parentheses out on purpose because what I want you to keep in mind is that the minus sign was in front of this entire second expression. So that minus sign is still going to need to be in front of all of it. And essentially we need those parentheses so that we know that we need to distribute. So this is the natural log of e to the fourth. And that minus sign distributes through here. And I get the natural log of y. All right, so now we have some powers. And each of these powers, using my power rule of logarithms, I can take those powers and put them in front of each logarithm. So I can rewrite this. This is now 1/3 times the natural log of x minus 4 times the natural log of e minus the natural log of y. And we have one last piece that we can simplify. We know that the natural log of e, since the base and the argument match, that's going to turn into a 1. So my final answer here, I have 1/3 natural log of x minus 4 minus the natural log of y. And so this strategy is really helpful for us when we get to calculus and we start having to take derivatives of logarithmic expressions. Because if I expand it and I have all these little terms, then it's very easy for me to deal with. So let's look at one more example of expanding. So this example here, I have the log of the square root of x to the 5th over 10y to the 4th. Okay, so unpackaging this, taking the layers off. Work from the outside in if you can. So as we did in that last one, this square root can be rewritten as a 1/2 power. And that 1/2 power is going to apply to the entire argument because everything is under that radical. So I'm going to write it like this. Now I have two options here. I can take that 1/2 power and I can distribute to all three of my factors in the argument. But I find that students sometimes make a mistake there. So I'm going to go ahead and use my power rule and put that 1/2 in front. So by the power rule, I can now say, well, this is 1/2 times the log of x to the 5th over 10y to the 4th. And so in this situation, as we expand, we need to make sure that we are distributing that 1/2 to all of those logarithms. So I'm going to wait to the end to do that, but I'm going to use parentheses to keep it all grouped together. All right, so the 1/2 is going to be in front of everything. Okay, so looking at our argument, I see I have a quotient in there. And dealing with the quotient rule, that means I can separate this into two logs. Log of the numerator, x to the 5th, minus log of the denominator, 10y to the 4th. All right, as we did in the last one, we still have a product in here. I've got a product between the 10 and y to the 4th. And I put it in the second piece in both of these examples because I really like to illustrate distribution. So I'm going to rewrite this 1/2 log of x to the 5th. I still have my minus, and I'm going to subtract all of what I expand here. So expanding this second piece, I have the log of 10 plus the log of y to the 4th. Okay, so that minus will distribute, and what that gives me is 1/2 log of x to the 5th minus the log of 10 minus the log of y to the 4th. So just paying attention to that distribution. I see that's something that gets lost a lot, so I really like to point that out when I'm doing my examples. Okay, so now we can use our power rule because I have a x to the 5th and an argument of y to the 4th. And you may be saying, well, Ms. Stone, why didn't you put parentheses around that argument for y to the 4th and you did for x to the 5th? It's really just a preference. I should write the parentheses as I'm learning to understand them, but as we understand them better, we can leave them off. Okay, so, but to be more proper, I'm going to keep those parentheses there. So back to using my power rule, I now have 5 times the log of x minus the log of 10 is going to turn into 1 because that's log base 10 of 10. And when the base and the argument match, the logarithms equal to 1. Minus 4 log of y. My last step here would be to distribute that 1/2. I have 5/2 log x minus 1/2, and then the 1/2 times 4 is minus 2 log of y. And we are done.